if you would add in the project, is called Mason line string. That's nylon Mason line string. And you can get that at Lowe's. That would help you out. The reason that's good now, who asked about paracord? Is paracord kind of like that, or who asked about paracord? Miss, I don't know if it's Mr. or Miss Fowler. Would paracord, is that like paracord? Okay, you there, Fowler? Fowler's not there anymore. They might have went back to sleep. Kind of paracord is a little thicker. Okay, the reason you're using, let me tell you the reason you're using the paracord. Let me show you. Okay, here's why you're using the paracord. You're going to have to use a protractor. The bigger the protractor, the better. They used to sell these big ones, but they don't sell them now because people don't use them because I guess I don't know why. But you're going to use a protractor. And I wish I had one with me. I don't have one. The protractor looks like this. And you're going to pull a 25-foot string and you're going to tack it down. I say do it in a parking lot or driveway, okay? Because a driveway or a parking lot, and use like duct tape to tape it down at a spot right here and then put your duct tape over it, and then a spot right here and a duct tape. And I would use even footages. I would not use 25.6. Use 27 or use 32. Do not use decimals, okay? And make this, let's say 30 foot. And then you put another point out here and you measure that distance at, let's say 25 foot. And then you pull the string between there, and then you lay the protractor down and you get a degree where it's hitting. That's what you're using the string for, okay? And you're using the string, you're also going to figure out the area in this using basically Pythagorean theorem as well. And you're going to, and you could, and what you're going to do is you're going to find this distance right here. You're going to find that distance using trig, and then you're going to test it with the tape measure to see if you're in the right area. That's the whole point of this. The other one is if you have a, let's say your trash can in your driveway. I'm just using a trash can because it's in the driveway. You can use a fire hydrant in the middle of a parking lot, a pedestal, a light pole pedestal in the middle of a parking lot, anything. You would pull a string from that pedestal, from the middle of that pedestal to your point, and you would tape those down with a piece of duct tape, because you can't drive a nail in the concrete. You can, but you don't want to do that. And then you'll pull a string from that point to the height, to the height of that pedestal or trash can. And you're going to lay your protractor down and get that angle. Get this angle right here. And then you're going to figure the distance right here. You're going to figure that distance and check it. And you'll have this distance right here of 30 feet. And of course, you don't care about this distance because that doesn't help you. This is what you're finding. Okay? This X and maybe this X or this X if you find this distance. It's just a little exercise to show you what trigonometry is used for. And this trash can is supposed to represent like a water tank. You know, water tank that you can't climb on top of, and you're using trigonometry to figure out the height of the water tank. Okay. Now, nowadays, with the computers that we use, and like the theodolites and the HPs hooked to the theodolites, we don't have to do this by hand anymore. But it is a nice little drill, a nice little exercise to show you how trig is used in the computer applications. So you got a horizontal angle that you're finding right here. And let's say this is your, let's say this is in your driveway. Let's say this is your driveway, and you just draw 3 points in your driveway. Or, you know, it could be across the driveway or whatever. You could use this point right here and go across the driveway and then go down here to the end of the driveway and figure this angle right here. Okay, right there. You could do that because you would have this distance, let's say 20 feet, and then you would have this distance of maybe 25 feet. And you know that angle because you lay your protractor down. You would lay your protractor down like this, and you would get that angle right here. Does everybody see basically what we're doing? That's the two experiments. One is a horizontal angle. The other is a vertical angle looking up a height. Anybody got a question? That's basically, so read over the experiment, read over it, and I'll go into it a little bit more. And with the practical application that we're doing in 9.4, it's going to fall right into place.
Is there like a set due date for this yet?
No, they don't have a due date.
All right, didn't think so.
So when I give you the updated original, not the rough draft, then I'll know more about it. You take pics of your string spread out and your chalk lines or whatever you want to use. Does the ground need to be completely level? Yes. Now you bring up something good, Winchester. When you're surveying, distances have to be precise. So you can't just lollygag around. You have to pull the tape tight and put the dot on 25 feet exactly. Okay, you got to be the level. It needs to be level. Yes. Okay. Now, all right. Now, if you have do you have a asphalt driveway or a concrete driveway, Winchester, Mr. Winchester? Is it concrete or asphalt? Okay, asphalt's fine. We're not talking, okay, this is what I'm talking about, unlevel. All right, that's unlevel. You don't want to, if your driveway is right here and this is like a foot difference, 1 foot, okay, you don't want to use this, okay? But if you've got a driveway that looks something like that, you know, would this be in the middle, this being the left side and this being the right side, that's not bad. Okay, if you have an asphalt drive or an asphalt parking lot or a concrete drive or a concrete parking lot or a basketball court is fine. 25 is the minimum. You can make them long as you want. If you want to make 100 feet, knock yourself out. But make sure you measure real. You got to measure, and 2 people need to do this. If you got a partner, y'all can do it together. I don't know if I can let y'all do it together as far as a project, but I will check on that. I mean, I don't care, but this is not my project. This is the bureaucrats and administrators. That's not even in our department. So I got to check on that. But yes, you can make them as long as you want. I would say the minimum is 20 or 25 feet. Make it 25, whatever the project says. So we just use a hard surface. I would not use grass or in the dirt unless the dirt is very packed, because y'all are gonna have enough trouble doing the string and the distance without the grass and the lumps of grass and all that. Let me just say this. If you've got a flat surface, that can be dirt. That can be, what I mean by dirt. Well, some people, you may have like I've got a barnyard that, outside of the barn is flat as a flitter and the tractors run over it all the time and it's very hard. Okay. So you could have a very hard dirt surface. You could have a concrete, or you could have asphalt. I would suggest, and most of y'all live in apartment complexes, go out one that's already done for you is a parking space. Now you might have to add to those parking spaces because they're only like 12 feet. Can you use the parking spaces as a guide? Yes. I would highly suggest using the parking spaces because they already have vertical lines. I mean, they already have straight lines. That's a parking space. You can extend it 25 feet and turn another angle. You can do all kinds of things. Just make sure it's a triangle when you're finished. You need to draw a picture of it. Take a picture of it, and you may have to draw a picture of it. I don't know if it says draw a picture or not in the project, but I guess taking a picture would be just as good. Okay? All right, that's enough of that. Go ahead and read over it, and we'll go over it more because I'm not going to make it, besides I don't want to do it, I'm not going to make it that hard on you. All right, all I need y'all to do, this is what I need y'all to do. I need y'all to go through the motions, use the string, tape it down, take pictures of it and write it up. If you do that, I think most of you will be okay. So if we use the driveway, is it the width of the driveway that matters or the length? Doesn't matter as long as it's 25. And make sure it's straight. Okay, the reason I would suggest a parking space, and I'll tell you why. Everything we have in Trig is based on what? A 90-degree angle, right? It's based on a 90-degree angle. So if you use a parking space, the curb is right here. What is the curb to the parking lines? They're 90 degrees. So you know that you can use this. You can extend the curb. Let's say go down the curb 30 feet. And let's say there's another parking space right here, 15 feet and 15 feet. You go down the curb 30 feet. And then you go down the parking space 40 feet. Okay? Well, you know this is 90 degrees, so you know that this is a right triangle. Does everybody see that? Now that's a horizontal angle. That's with it on the ground. Okay? So all you would have to do is tape or have somebody stand on a piece of string at this dot, because you don't need a piece of string here because you're using the curb. Okay? Curb is very visible. You're using this. Now you would need to put a piece of string from here to there, the 40 feet. You would need a piece of string right here, whatever that distance is. And then you would need a piece of string taped from here to here and take a picture of it. And that way you'd have it in your phone. That way you could use it for the project. Okay? So that's a good horizontal. Okay? Those of you that, live near Lowe's, you could go out to a Lowe's or a Wally World and you see parking spaces like this. You could actually, let's see, grab this one. You could, you wouldn't have to use a string. You would just put it like a square block there, like with chalk, and go through here. And that's, let's say it's 12, that's 12, that's 12. That'd be 36 feet. And then go out here and just go to the end of this to be 12 feet. Since this is 36 feet, that's over 25 feet. you can do this and then put a string from that parking space corner to this parking space, the parking line, and then draw put a chalk and a dot right there, chalk and a dot right there, chalk and a dot right there. Take a picture of that, and then you can do the math after you lay don't forget, you got to lay your protractor down and get an angle. Now, of course, the angle is going to be to the nearest whole number, okay? Because a protractor cannot measure the minutes and seconds. So everything's to the whole foot and the whole number. So let's say this is 61 degrees, and you measured this at 12 feet and this at 36 feet. Take a picture. You've got everything you need. Draw a picture of it so you have all the correct information on it. Boom, you've got what you need for the project for this part. Now the vertical angle, I'm going to do this again. The vertical angle, you're going to go and find something with a flat surface, whether it be a parking lot or driveway, and then put something in the driveway. Let's say you have a basketball goal, and it's one of those short ones, because you don't want to measure something that you got to crawl up on a ladder and break your leg and all that. Don't do that. Let's say you got one of them short, them basketball goals that, come down to like 6 feet. It's got one of those mechanisms on it, and you can make it go up to 10 feet, but it's got 6 feet. Let's say this is 6 feet. And you do this, and you measure out 25 feet here, and you put a string going here and a string. And since we're measuring the pole, let's measure the pole. Have a string going from here to here, and then put your protractor right here and measure this angle. You've got this distance. You've got this distance. Well, you don't need this distance, okay? You're going to take this angle and this distance, and you're going to calculate this angle right here, the height. And then you're going to check it by measuring it and see how close you get. So you would take a picture of the goal with the string coming down, tie the string to the goal, bring it down, put a brick on it, or if you're in asphalt, you can actually drive if it's hot, it won't, but use duct tape or have somebody hold that there. And of course, you don't need a string but it would help if you had a string from here to here, tie it to the pole or tie it to the goal post, and have the person hold it right here. Lay your protractor down right there. Just take a picture of all three things, and boom, you're done with that one. The rest of it's writing it up in a presentation. How's that? Does that go over it pretty good? At least for a rough draft?
Yes, sir.
Okay. That's what the string and the protractor's for. So just be accurate, be professional, do the best you can with it, and then write it up. Make sure you take pictures and draw a schematic so you have everything, so you don't have to go back out there and do everything over. All right, let's get to the questions because I spent too much time on that. All right, questions I have. And, okay. 111. Okay, let's put them in order if we can, or let's see what happens. There we go. 9.3. Let's see if they're in order. 9.3, 55, 57. Okay. 9.3, 55/23. Give the reference angle for the measure of 1870 degrees. This is a good standardized test question. I don't ask but a couple of these if I do on the test, but standardized test questions, they love this question for some reason. I don't know why, I guess because it confuses students. Okay, first thing we're going to do is we're going to draw a crosshair. And we know that 360 degrees is one from 0 to 2 pi, or from 0 to 360. You know that's one revolution. So I'm going to take 1870 and I'm going to divide by 360. So I'm going to take my handy dandy calculator and I'm going to take 1870 and I'm going to turn the damn thing on first. 1870 and I'm going to divide by 360. I get 5 revolutions. So 5 revolutions, 1, 2, 3, 4, and 5. I get 5 revolutions by that 5 right there. So let's multiply 5 times 360. So 5 times 360. That gives us a total of 1800 degrees. 1800 degrees from 1870 is what? 70 degrees. So our reference angle is 70 degrees. And that 0.19 would be right about there. And that is basically your reference angle is 70 degrees. That's how I do it. Now, there are other ways to do it, but that's the way I do those questions. So your answer should be 70 degrees. And you feel good about yourself. Next, 9.3, 57/24. Probably the same type question. 7 pi over 6. Now, there's 2 ways you can do this one. One is to take it away from 2 pi. Okay. 3, and the second way is the way I do it. I want to know what I'm dealing with. So 7 pi over 6. 7 pi over 6 multiplied by 180 over pi. Well, the pi's cancel, and that leaves 180 divided by 6 is 3, right? 30, sorry. And that's equal to 210 degrees. Well, 210 degrees is within 180. So, 360. So you can do this by subtracting from 2 pi, or you can do 210 degrees is your reference, your angle. So that means 210 degrees is somewhere in here. So 210 from 360 is 150. So that means your reference angle is 150 degrees. Now you got to change 150 degrees into pi, radians. So 150 degrees over 1 multiplied by pi over 180 degrees. So the 180s of the degrees cancel out. And that's going to leave you with, well, the zeros cancel also. 15 pi over 18, or 3 pi over what? 6. Now, the other way is to take 2 pi and subtract 7 pi over 6. So let's do that. Give y'all a second to catch up.
Can't that 3 pi over 6 be reduced more?
Yes, I'm sorry. That'd be what, pi over 2? Sorry. Who said that? You did a good job. Okay. So now I'm going to take 7 pi or 2 pi, which is 1 revolution, subtract 7 pi over 6. Well, this is 2 pi over 1, so I got to make, let's see, that's going to be 6 and 6, and that's 7 pi. And 1 will go into 6 times. 6 times 2 is 12. What's 12 minus 7? Well, I got 5 pi over 6. Well, that's something's wrong. I must have messed up on my math.
Wouldn't you subtract 7, or wouldn't you subtract pi over, or pi minus, or wow. 7 pi over 6 minus pi, because it's in the third quadrant. You're not subtracting from.
That's it. Well, I still should get the same answer. Yeah, I see what you're saying. But I still should get the same answer from 360. Okay, 15 pi over 8 wouldn't be reduced to 5 pi over 6. Okay. Well, doesn't 6 go into 18 3 times?
Yes.
I thought that 5 pi. Why do you got 5 pi? I don't see. Okay, you said 5 pi, but how do you get 5 pi from this? Because I don't see. I've got an error somewhere. I don't believe it's in the 5 pi over 6. I've got an error, I think, over here. Let's see. I think the error there, 5 pi over 6 is the answer. Let's check. No, pi over 6. Okay, I've got something wrong somewhere. Now, you may be right. They may be wanting the reference angle to 180 or 270. Let's see if that's what they're wanting. Let me see, because the two, let's see, what did I say, 210? 210 falls right in here.
Yeah.
So they may want it from 3 pi over 4. They may want this angle right here.
3 pi.
Let's see. Let's see. Okay, so we got 5 pi over 6, or what, 7 pi over 6? So 7 pi or 3 pi over 4 minus 7 pi over 6. Well, the common denominator is 12. So 12 here and 12 here. 6 will go into 12 2 times. 2 times 7 is 14 pi. 4 will go into 12 3 times. 3 times 3. Well, that's not even. That's not right.
Wouldn't it be 3 pi over 2, because 3 pi over 4 is smaller than pi?
Thank you. 3 pi over 2. That's better. I'm sorry. Hold on. Can't see the board. Okay, 3 pi over 2. 2 will go in. Yeah, 6 times 3 is 18 pi. And 18 minus 14 is 4 pi over 12. And that's going to be pi over 3. So that angle right here is pi over 3. See, I'm confused on what they're wanting, because they're getting pi over 6, and evidently I've got something totally wrong.
Well, yeah, our textbook wants us to do it back to the x-axis, not the y-axis. So it would be.
Well, that's.
It would be minus 180, or theta minus pi.
That would be.
Would give you theta prime.
Okay, thank you for telling me that, but that's ridiculous. Because why are you going to give the reference angle under the angle that you've got?
I think our textbook defines the reference angle back to the x-axis only, not to the y-axis.
Okay, well then I'm thinking to the 360. Okay, well that's where the practical app override. I'm thinking practical app. I'm not thinking. Okay, so to the x-axis. So here is there's 7 pi over 6. 7 pi over 6. They want the reference not to 360, but to that angle right there, to the x-axis.
We can't see your board.
Okay. So let's try that. We know this is pi. This is pi over 2, and this is 0. This is 3 pi over 2, and this is 2 pi. All right, so if I take pi away from 7 pi over 6, that's going to be pi over 1 minus 7 pi over 6.
We still can't see your board.
So I can't see your board.
I'm sorry.
And also the book says it would be theta minus pi because we're going back to the x-axis, therefore it was bigger than 180.
You're right. I'm thinking of plus. This is just a screwed up problem. All right, it'd be 7 pi. You're right. 7 pi is greater. It'd be 7 pi minus. Well, you could take the absolute value, but I'm not going to go there. So 7 pi over 6 minus pi over 1. And you got to get a common denominator. And that'll be 7 pi, and 1 we're going to 6. That'll be 6 pi, and you're left with pi over 6. I apologize for that being a problem, but I'm used to doing it to 360. I'm sorry. And the reason I was messing up was because I'm still thinking about the 360 right here. I'm still thinking about that while I'm trying to figure out how to do that. So anyway, I was doing it to 360 degrees. And for some reason, there we go. I was doing 360 degrees right here. So I apologize for that miscommunication between me and the book. Sorry. Technically, if you're talking about the x-axis, you could be talking about 360. But they're talking about the closest one, and happy birthday. That's great. All right, so hopefully I didn't mess you up too much. That would not be a good test question. All right, this one is 9.365/28. Okay, find the exact value of the 6 trigonometric functions of the angle 1680. So let's go to 1680. And this is a good test question. I like the ones like this because they can't screw it up with the academia. They can't screw it up. You have to do it this way. You have to do the 360. So I'm going to take my handy dandy calculator, and I'm going to take 1680. 1680 divided by 360. All right, I got 4 revolutions. So 4 times 360. 4 times 360 is equal to 1440, and subtract that from 1680. 1680 minus 440. 1440, sorry. That's 240 degrees. So minus 1440, which is 4 revolutions at 360, is equal to 240 degrees. Well, let's see where 240 is. 240, that's 180, and add what? Or 270 minus what? 270 minus 60, right? Or 270 minus 30, right? That's 30, so this would be what? 60. Everybody with me?
Yes, sir.
So this is, hopefully I don't screw this up like I did the other day. That'll be -1. That'll be the square root of 3, and that should be 2. And that'd be negative. So I'm going to draw this big triangle up here. And I'm going to put a -1, negative square root of 3, and 2. And my angle is right here. So that means that my little man has got the adjacent, opposite, and hypotenuse. Sine, I'm just going to do the first 3. Sine, I don't know what it's asking, if it's asking for all of them or not. Sine, cosine, tangent. Oscar had a hunk of apple. Oscar had negative square root of 3 over 2. A hunk, -1 over 2 of apple. Negative square root of 3 over -1 is positive square root of 3. And that should be your 3, and then you just do the reciprocal to find the other. So cotan would be, let's say this is the square root of 3 over 1. That's -1. I'm going to put negative and negative right here. So that's going to be -1. It's going to be positive, which would be 1. This would be positive, which would be 1 over the square root of 3, which would be the square root of 3 over 3. And remember, all students take calculus. The tangent and the cotangent are going to be what? Positive. And then the secant is going to be -2. And then the cosecant is going to be 2 square root of 3 over 3. Sorry. Let me get rid of this. So I'm not going to type all those in. I'm going to type them in and let y'all see what the answers are. Hopefully we got them right, unless I had another brain bubble. They just wanted, so I can type those in. Negative square root of 3 over 2. And that's going to be -1 divided by 2. And that's going to be square root of 3. And you should feel good about yourself. I like that one. That one's a good test question. Okay. Hopefully that'll help you out. Sorry about that fiasco on the last question. All right, 9.3, 77/31. All right, secant of 2230. I think we did one like this one, but I'll do it again. This is a calculator drill, so first thing I'm going to do is write secant, sine, cosine, tangent, cotangent, secant, cosecant. Okay, they're asking for the secant of 2230. The secant of 2230. Well, the secant of 2230 is also 1 over the what? Cosine of 2230. So if you do the secant of 2230, it's going to be the same number as 1 over the cosine of 2230. This one you can do in your calculator. So you take your handy dandy calculator. Make sure it's in degree mode. Mode. Turn it on first. Mode. It's in degree mode. And I'm going to type in 1 divided by parentheses cosine. Can't find the cosine button. Cosine of 22 second, apps, degrees, 30, second, apps, minutes, close parenthesis, equals. I got 1.08. 1.0823922. So that way, when they tell you to round, you'll have everything you need. So it says round to 8 decimal places. 1.0823922. Well done. And that's a test question because it's short and to the point. I don't like questions that are tricky like that one. 9.4, number 3, and this will get us into our practical apps section. All right, here is a nice triangle, and of course it's 90 degrees. So everything, I'm just going to blow this up so you can ignore what it's asking because I really don't care about what it's asking. And it's not going to let me. Okay. There you go. So I want you to draw. I don't want you to worry about what they're asking. We're going to draw. I'm going to draw this. So got a triangle. That is got angle A, angle B, and angle C. Now I'm going to show you a trick learned in the war. Okay. In geometry and trigonometry, when you have a triangle, the side across from angle A is going to be called little a. The side across from angle B is going to be called little b. And the side across from angle C is going to be little c. Is that true 100% of the time? Yes or no?
Yes.
It is true 100% of the time. Okay? 100% of the time, it's true. So you need to get used to that. Now, who am I talking to? I'm talking to those people that hadn't had geometry in a few years and have had no trigonometry at all. Okay? You always go from the capital to the lowercase with the opposite. Capital to lowercase. Capital to lowercase. Capital letters are usually the angles. The lowercases are usually the sides. Okay, with that being said, let's look at the question. B is equal to 101. And C is equal to 4.11. Now, what can we do to find A here? You do two things. Oscar had a hunk of apple. We've got the, if I want to find A right here, angle A, then I can do Oscar had a hunk. I could do the cosine and put 101 over 411 and take the inverse sine, and that will find the angle. That won't give us little a. Little a, you're going to have to, that's the opposite. We don't have this angle yet, so we're going to have to use Pythagorean theorem. So Pythagorean theorem, if I know how to spell theorem. I haven't spelled it since college. All right, so Pythagorean theorem. A squared plus B squared, did you check it? I hope I spelled it right. Equals C squared. Did somebody check me? Thought I heard somebody say something. Okay, so the legs, it doesn't matter where you plug it in. Since A, we don't have it, I'm going to leave that A. B is 101. So A squared plus 1.01 squared is equal to 4.11 squared. I think I'm going to pull this up now because I don't care about what they want. So I take my handy dandy calculator and I do 1.01 caret 2. That's 1.0201. A squared plus 1.0201 is equal to 4.11 caret symbol 2. 16.8921. 16.8921. Now, A squared, take this across the river, it becomes a negative. And that's going to give me, well, the ones cancel. 2, 9, that'll be 7, 8, and 15. But I'll check it. So 16.8921 minus 1.0201, 15.872. And now I take the square root of both sides. And A is equal to, raise this to the 0.5 power, I'm going to write everything, 3.983967871. And that's the side A. Since these are to the tenths, we're going to round A to the 10th, 3.98. Now I'm going to show you how to find the angle. And so you're going to be using this on your what you call it. Sometimes you need to find an angle, whatever the case may be. And let's see, what else? Here we go. We can go down here. Let me go. So you found angle A. You found the side A. And now we want to find angle A. We're going to call it theta. Okay? So sine of theta is equal to, Oscar had 3.98 divided by 4.11. Now, do realize that we are rounding our numbers to the 10th. So that means that our accuracy, the more that you round, the less accuracy you have. If you keep your numbers out to the 8th or 10th digit, like with the calculator, you will have very accurate numbers. Okay, so here I'm going to do this. So 3 divided by 4.11. And that sine of theta is equal to 0.96933352485. All right, now watch what I do here because this is very important. I want theta by itself. So I'm going to divide by the sine. Well, I don't need the sine in the denominator. So theta is equal to the inverse sine, bring it upstairs, it makes it a -1, of 0.96933352485. And now you just do that in the calculator. So second sine second answer parentheses. So my angle is 75.77 degrees. Theta is equal to 75.77 degrees. So this angle is equal to, and I'm going to put it in pink because we found it, as well as A. We found A also. So that's equal to 75.77 degrees. So somebody tell me how I'm going to find angle B. There's two ways. You can do, you put your little man up here, or what's the easiest way?
Sine of B, probably.
Or add up 90 in the.
Subtract it from 90.
Yeah, yes.
That's the easiest way. I know what you were saying.
Yeah.
You were going to say add them up and take them away from 180.
Yes, sir.
You can either do that or you can subtract it from 90, because this degree and this degree is equal to 90. So 90 minus 75.77 is equal to that angle. And I'm going to take my handy dandy calculator and I'm going to go 90 minus second answer. Some of y'all just figuring out how to use second answer. Y'all so happy. And that's equal to 14.23. So 14.23 degrees. Is this a test question? Oh, yeah. In fact, I'm going to tell you right now, 9.4 is going to make up a majority of your test questions. So how would y'all like to do another one of these? Raise your hand. Let's see how many hands we got. Who would feel comfortable doing another one? Now, how about that? All right, I got at least 8 or 10 of y'all. So go ahead and put your hands back down, and we'll do another one. And the reason we're doing another one is this is what I would be going over if I was explaining 9.4 to you. So I might as well just do the ones that they give you. Okay, 75.8 degrees, yep. And B would be 14.2 degrees. And that's all they asked. There we go. There's A. Round to the nearest hundredth, 3.98. And we feel good about ourselves. Similar question. All right, I'm going to let y'all do this one. I'm going to put you on the timer. I'm going to give you 3 minutes, at least to get it started. 3 minutes. And if you can't do it, what do we chalk that up as? Failure, Hubert. That's right, class. You gotta be real. If you don't succeed, you fail and quit. Right? Because shut up, Hubert. Shut up. I was fixing to say somebody will take care of you, but I'm not going to say it. The federal government will take care of you. How about that? One of my students in my last class told me that I need to make sure I get out and vote. I said, you haven't been to my Facebook page, have you? She said, no. I said, well, you need to go to my Facebook page. You may not want me to vote after you see my Facebook page. It's a joke. Y'all just ain't gonna comment on anything today, are you? Oh, but let me make a mistake, and oh my God, y'all just go crazy.
I think it's just because we're trying to concentrate.
Oh, I'm sorry. I'll shut up. I suck. Okay, so y'all should be finished by now.
Yes, sir.
All right. So this one, angle A, angle B, angle C, little a, and little b. And they give us B is equal to 1.13 and C is equal to 4.43. So I'm going to go ahead and do the square root of 4.43 squared minus 1.13 squared. Now, if you're in a hurry, you can just do that right there. And you don't have to write down everything that I wrote down on the previous problem. And you take your handy dandy calculator and you do square root. You may be able to do this. If not, then you have to do it step by step. So I'm going to take parentheses. Turn it on, dork. Sorry, I'm kind of abusive to myself. 4.43 raised to the second power minus 1.13 raised to the second power, close parentheses, raised to the 0.5 power. I'm taking the square root of 4.43, blah, blah, blah. I get 4.28 and so on. So A is equal to ... And I didn't tell you about Dr. Harden at Clemson. Dr. Harden at Clemson was about 5'2", and he weighed about 100 pounds, and he grunted to his class whenever he didn't want to talk. So I had him for first variable calculus and second calculus, and I had him, he was my advisor. After I switched from civil engineering to mathematics, he became my advisor. So I learned his grunting very well. And in fact, if you go down at the bottom of Martin Hall and you go in the back door of the stairwell and look to your left, they've got a little plaque with his name on it. That was his office. And he would grunt. And whenever he wrote these three dots, he would go, yeah, and that means you know what to do. So, so that comes out to be 4.283456548. When you go to Clemson or a research university, you're going to have professors that's going to make a memory, and you're going to tell people that you work with about that professor. I tell all my students about Dr. Harden, Hardin. Actually, one of the buildings is named after his family, Harden Hall. Anyway, to make a long story short, he grunted all the time. And he was 5'2", and he couldn't reach the blackboards that slide up and down, so he used to stand on a little bucket type thing. All right, I'll shut up. So A is equal to 4.28. And you feel good about yourself. Now I'm going to find angle A. We're going to call it theta. Sine of theta equals Oscar had 4.28 divided by 4.43. Now again, the reason I'm using 4.28 and 4.43 and I'm not using this is because they tell us in here that they go to the 10th of the hundredth. So that's why I'm using to the hundredths. And that's going to be theta is equal to the inverse sine of 4.28 divided by 4.43. Let me ask y'all a question. Could I have done the cosine? Yes or no? Yes. Could I have done the tangent? Yes. What do we have? We have all three what? What do we have? All three what?
All three sides.
If you have all three sides, you can use any trigonometric function. I wouldn't use the reciprocal functions. I wouldn't use cotangent, secant, and cosecant unless you just like pain. Okay? But you could use the sine. Let's use the cosine. Cosine of theta. Oscar had a hunk. A divided by h. So 1.13 divided by 4.43. Tan. Oscar had a hunk of apple. So that would be 4.28 divided by 1.13. So this would be theta is equal to the inverse cosine. Now I want somebody to do the cosine and the tangent for me. Divided by 4.43. And this would be theta is equal to the inverse tangent of 4.28 divided by 1.13. Move this over, sorry. I'm going to do the sine, and I want y'all to do the cosine, the inverse cosine, and the inverse tangent, and see if y'all don't get the same thing. So 4.28 divided by 4.43. And second, inverse sign, inverse answer, close parentheses, I get 75.05 degrees, or 75.0 degrees if they tell us to round to the 10th. Okay, somebody that did the inverse cosine, what did you get? Oh, come on. Somebody had to do the inverse cosine. Did anybody do the tangent? Are y'all even?
Here, I'll do the cosine right now.
Huh? Okay. Inverse cosine, parentheses, of 1.13 divided by 4.43.
It's 75.22.
There you go. It's a little bit off, but that's because we didn't carry it to 8 digits. That's why. If you carried it to 8 digits, it would work out to be the same. Inverse tangent of 4.28 divided by 1.13. 75.21. So it does come out to be, supposed to come out to be equal, and if we were using all 8 digits, it would work out that way. But this question, they don't want you to do it both ways, but I'm just telling you, you can if you decide to do it that way. So now we just take our handy dandy pink, and we're going to take, where am I at? We'll take 90 degrees and subtract, let's see, 75.05. And heck, what's that going to be? Like 14.95? What does it come out to be?
Yes, sir, 14.95.
And that's angle B. Of course, my rounding, I don't know if they want me to round to the 10th or to the 100th with the angle, to say the 10th. So that'd be 75. And B would be 15. And angle side A, round to the nearest 100th, be 4.28. Now I bet you feel better. What do you think? Feel better now?
Yes, sir.
And we are over time. I'm so sorry. I'm sorry. I get doing these practical apps and I forget all about time. So I'm so sorry. Let me go ahead and check the roll to make sure anybody I already got it pulled up. So just give me a second.